Today we will discuss about DC generator. Okay, so DC generator. DC generator means what is actually DC generator? DC generator means which converts mechanical energy to electrical energy, that is called as a DC generator. Okay, so DC generator is based upon your Faraday law of electromagnetic induction. Okay, what is Faraday law of electromagnetic induction? Everybody knows what is Faraday law of electromagnetic induction. Faraday law of electromagnetic induction, first law says that whenever a conductor is placed inside the magnetic field, an induced EMF is generated. Okay, whenever a conductor is placed inside the magnetic field, an induced EMF is generated. Second law, the induced EMF is directly proportional to rate of change of flux. That means, see here, this is your north pole and this one is the south pole. Okay, if you place a conductor inside the magnetic field, okay, so magnetic lines of force always passes from north pole to south pole. So here, whenever a conductor placed inside the magnetic field, an induced EMF is generated. Here, induced EMF, EMF, that is E. Okay, so this induced EMF E डायरेक्टली प्रोपोर्शनल टू सेकेंड लॉ. जो सेकेंड लॉ है, इंड्यूस ईएमएफ इज डायरेक्टली प्रोपोर्शनल टू रेट ऑफ चेंज ऑफ फ्लक्स डी फाई बाई dt. Clear? So the induced EMF is directly proportional to the rate of change of flux, and you know E is equal to minus n d phi by dt. Minus side indicates due to the Lenz's law, okay, negative half cycle. So here, so basically principle of DC generator is whenever a conductor placed inside the magnetic field, an induced EMF is generated. That is the principle of DC generator, and it is based upon your Faraday law of electromagnetic induction. North pole, south pole, concept is said, induced EMF is generated E, and this E is directly proportional to your d phi by dt, that is rate of change of flux, and it is also based upon Fleming's right hand rule. You know, this is the Fleming's right hand rule. Okay, this is the thumb and this is the forefinger and this is the middle finger. So this thumb shows the direction of conductor and this forefinger shows the direction of magnetic field, and this middle finger shows the direction of current, and all the fingers are, you know, this is 90 degree right angle with each other. Okay, so it is based upon Fleming's left hand rule. Fleming's right hand rule. Okay, and the Fleming's right hand rule is based upon your DC motor. Okay, so what is DC motor? DC motor converts electrical energy to mechanical energy. Okay, understand? DC motor converts electrical energy to mechanical energy, and that is based upon Fleming's left hand rule. So what is Fleming's left hand rule? You know, this shows the direction of force and this is the forefinger shows the direction of your magnetic field, this shows the direction of current. So in case of motor, when a current carrying a conductor is placed inside the magnetic field, a force it experiences a force, that is F is equal to BIL Newton. B plus density, I is the current carrying conductor, L is the length of the conductor. So F is equal to BIL. So these are the concept about your DC generator and DC motor. So DC generator is based upon Fleming's right hand rule, and DC motor is based upon your Fleming left hand. And all the fingers in right hand rule and left hand rule, they are perpendicular with each other. Means they have 90 degree perpendicular, 90 degree. Okay. And what is the EMF equation of DC generator? What is the EMF equation of DC generator? You know EG, that is EG is equal to N phi ZP by 68. This EG is nothing but generated EMF, and this N is nothing but number of rotation in RPM, revolution per minute, and this phi magnetic flux per pole. Okay, and this is the Z. Z is the armature conductor, and this is the P pole, and this is A is nothing but your number of parallel paths. So this is the EMF equation of DC generator. So if anybody will ask you what is the EMF equation of DC motor, that is EB is equal to N phi ZP by 68. You understand? That is EB is equal to N phi ZP by 68. So here it is back EMF. Here it is back EMF, but here it is generated EMF. Okay. So in generator there are parts. Some parts of the generators are. What are the parts? Magnetic field, armature conductor, commutator, and brushes of DC generator, and the outer part is yoke is present. So you know magnetic field is having north pole and south pole, and magnetic lines of force always passes from north pole to south pole. Armature conductor is a rotating device which is present inside the magnetic field, and it is able to rotate inside the magnetic field. Okay, and commutator is present. Important is that commutator. What is the function of commutator? It acts like a rectifier. Means here you see here, this is north pole, this is south pole, and here the armature conductor is there. Okay, this here I am showing diagram here. This is brushes and this is the load. Okay, so always you know north pole to south pole magnetic lines of force. Suppose this is A, B, C, D, and it will rotate as a B, D, A, B. Okay, again it will rotate as a B, C, D, rotating device. So this is north pole, south pole, and here it is nothing but your commutator. Here generated EMF is in AC form. मतलब क्या है, इधर जो जनरेटेड EMF होता है वो AC होता है. वो जो AC को हम कैसे करेंगे कन्वर्ट DC को कम्यूटेटर. सो कम्यूटेटर का काम क्या है, which convert AC to DC. अंडरस्टैंड, कम्यूटेटर का काम है कन्वर्ट करेगा AC to DC. Okay, so inside the commutator number of commutating segments are present. Okay, commutator segment is nothing but two hemispherical copper segment separated by a insulating material that is called mica, MiCa, mica. Everybody know that mica is the insulating material. So these are the parts of, you can say this is the parts of DC generator. The outer part is yoke, which is made up of cast iron. You know about. So types of DC generator. Types of DC generator. DC generator types. 1. Self-excited. Another separately excited. Self-excited and separately excited. So basically self-excited again divided into 3 types. Okay. Can anybody know what are the types? Series. Okay. Series, shunt, and compound. Understand? Series, shunt, and compound. So, in case of separately excited, your armature winding and field winding separated. Okay. But in case of self-excited, it have a 3 DC generator, that is series, shunt, compound. Okay. So let me know. This is your armature winding. Okay. If it is connected in parallel, then it is shunt generator. Armature winding connected with field winding in parallel, that is shunt generator. If your armature winding connected in series with field winding, that is series generator. Combination of series and shunt, we have compound motor. Compound motor is again classified into 2 types: long shunt, short shunt. Okay. So here here the EMF equation of series motor. This is RSC. This is RL. So here EG is generated, EG, and here the current is IA. Here ISC, and this is IL. So you can write easily EG minus IARA minus ISC RAC minus ILRA equal to 0. You can write. And here you can IA, ISC, IL both are same. IL, ISC and IA, all the currents are same. Understand?